Okay, hi everyone. If you are wanting to hear about mobile web performance, you're in the right place. If you're not wanting to hear about mobile web performance, you're still in the right place because you should be wanting to hear about it. So basically, the web, the mobile web, is the same exact thing as the web. But there are a few things that make the mobile web a little bit more breakable. And that's pretty much what I'm going to talk about, is how to not break the mobile web. So you want your mobile websites, or all your websites, in fact, to be fast to load, fast to render, fast to respond. You also want them to be fast to understand, but that's more of a UX talk, and I'm not covering that. You want them to be beautiful, useful. That is your PM's jobs and your designer's job. But making it eco-friendly is a developer's role. So in this talk, we're going to talk a little bit about the current ecosystem of mobile phones, performance concerns, and then some issues and solutions, some tips and tricks to actually improve or ensure that you don't break the mobile web. So a little bit about me. My name is Estelle Weyl. I am an open web evangelist at Instart Logic. We are in the business of delivering web apps and mobile apps super fast. And what I'm going to talk about today is everything that we don't do. I mean, everything that we do. So if you don't do what I tell you to do here, you can always just buy your product and make your site go fast. But since I'm an open web evangelist, I'm only trying to convince you to do it correctly and not need our services. I've also written what you call a shit ton of books. And for some reason, they're tiny because I'm not a good web developer and I didn't make them. Oh, that's weird that only those grow. CSS, the Definitive Guide, is coming out at the end of the summer, and Flexbox just came out about a month ago. Okay, so let's talk about the mobile ecosystem. In the United States in 2016, it's not really the United States, it's basically in the developed world, these were the top devices. As you can see, they're fairly not minimum wage, like not something you can buy every 6 months on minimum wage. But they have a decent amount of RAM, much better than the computers that you had 8 years ago. They have large hard drives, and most of them have dual-core CPU that are just basically awesome. In the United States, especially in the Bay Area, we think that everyone is connected. And this is basically a graph of the world, and there's 1.1 billion out of the 7 billion people in the world who have high-speed internet. There's only 3.2 billion people who are currently online. Only 3.2 billion, because that's less than 50% of the world's population. Close to 50%. In the United States, we have about 50, well, it actually says it here. We have 51 million people who are not online. In Indonesia, which is the orange one kind of near the top right here, they have 213 million people who are not online. They have 53 million approximately who are online. So they're the opposite of us, basically. But if you look at a map of their country, down here, oh, right here, you'll see it's completely green, which means they have the ability to they have coverage throughout the entire country. They could be online. And for those of them who are online and have mobile phones, these are the most popular devices in Indonesia from last year. We're talking, the FF stands for feature phone. So when you're thinking about the next 3.2 billion users, or at least the next billion users, these are the phones that you need to be thinking about. Their highest end phone, which some people can afford at in the $100 range, is a smartphone, but it has a 1 to 2 gigs of RAM, 16 gigabyte hard drive, and 1.3 gigahertz. But most of the people's phones have 32 to 64 megs of RAM. Your application might be using up more than that. You're going to crash the phone. So I did this several years ago when I bought a phone. So it's not a modern US phone. It's one with 3/4 of a gig of RAM. And when I bought the phone, turned it on, I had AT&T. It had apps already running by default. I don't know how to read it, but it's in the bottom line. It says 73 megabytes available, 255 MB plus 182 in 21. So I took it to mean that I had 73 megabytes available of RAM, possibly 255. But basically a quarter of a gig of RAM available for the browser, to run the browser, because it's already running the operating system. At this point, when I looked at this, my browser was not open. So when you have 2 gigs, you have a great phone, but that's not a real world scenario because not everyone can afford the iPhone, whatever number we're on, 27 at this point or something. So when we're talking about developing for mobile devices, it's really easy when you have the iPhone. They're all approximately the same size. There's like 4 or 5 different sizes now. Android there's probably over 10,000 different Android devices. The one thing is the aspect ratio of devices are approximately the same. They all kind of follow that red line. So they come in all different sizes, but they're rectangles. But we now have watches and they're circles. So generally, when you're designing, you want to do it on that aspect ratio. So feature phones are improving. They're definitely going up and to the right. So screen sizes are increasing, but some people like smaller screen sizes. CPU cores are increasing. We're now on average at 2, but I'm not sure if that's just the developed, wealthier markets. RAM is going up. At the left-hand side, it says 0.6, and now we're on average at 1.2. And NFC prevalence is also increasing. The thing is, when we're developing on these computers. This one has 16 gigs of RAM. This one has 2 gigs, and it's an older phone. So our dev environments are not our mobile, are not what people in the United States are when they're on their phones, and they're definitely not what people in Indonesia are experiencing. We should be developing, like, think of the paper plane instead of, turn your computer into well, not necessarily a paper plane, but at least a drone. Think of it as very low powered with a really good camera, because that's what most phones are. But they have browsers that are just as powerful as what you're running on your desktop. Another thing to consider about when you're doing mobile is battery life. Who here has their phone plugged in right now? We have 3 people who are charging their phones, right? Most people are not charging their phones when they're at the mall. They're not charging their phones all day. And depending on how much JavaScript you use and other issues, like when I'm on Waze, who here uses Waze? Everyone else should use Waze if you drive. It's amazing. So when I'm on Waze, I can just see my little battery monitor go down. I know that a native app is totally sucking up my battery power, but there's certain websites that also totally suck up battery power. Don't be that developer. Dawn said this like a year ago plus. Just because no one uses your mobile site doesn't mean you don't need to improve it. Maybe no one uses it because the experience sucks. Oh, wait, she was more polite than I am. And Stephen said this even longer ago, or no, same time, I guess. I remember when 3G was the primary mobile speed. It was slow, but it still worked. So why when my phone says 3G, it becomes completely useless? Most people blame, AT&T. Or Li-Fi. But let's just look at this stat right here. This is 2010, and the total average website was 702 kilobytes. And I want to congratulate all the developers in this room, because we did it. Yes! We just went over 3 megs. That's not something to be proud of. So our sites are 432% bigger. The middle circle, the radius is 2010, and the blue is 2007. If you're actually talking about area, it's a more legitimate comparison. It's still websites several years ago were tiny in comparison. We need to continue programming like that because page weight does matter. So someone at Google did this study, or did this trial thing. I'm not sure if people have heard of it, but I'll tell you the story. This was many years ago. And they decided to give themselves a budget. They rewrote YouTube, and they called it Feathers. And they gave themselves a budget of 100 kilobytes for everything other than the video. and 14 requests. They actually I think they gave themselves a budget of 12, but they ended up doing 14, and they were like, okay, let's do that. So when they released it, 14 requests at 100 kilobytes instead of 58 requests at 1.2 kilobytes, they noticed after 2 weeks that the average download time increased by 2 minutes. So they were like, WTF, we just made this website faster. How did this increase by 2 minutes? Because waiting 2 minutes for that cat video, when you lived in Siberia, it finally made that cat video accessible, because they weren't going to wait 12 minutes for a cat video, but they were willing to wait 2 minutes. And of course, I'm making a joke by saying cat video. But when they actually opened up new markets, because it was now possible to download within a reasonable amount of time. To us, 2 minutes is not a reasonable amount of time, but if you've never been able to access this content, 2 minutes is way better than 12 minutes. So by decreasing it, by making your websites fast, you can actually reach markets that you never would have considered. So what is involved in web performance? We have the time to download, which is downloading all your assets. You have to parse those assets. You have to execute, which basically means the parsing and the painting. And then you have the perceived performance, which is the user perception of the load speed and the reaction time. So we did a study, and I linked to it if you are interested in seeing it, and I'll talk about it a little bit later. But perceived performance is actually more important than how much it actually takes to download, because if your site takes 16 seconds to download and nothing happens until the 16-second mark, versus if your page takes 17 seconds to download, but you can see it from 2 seconds, 3 seconds, 4 seconds, people are going to think that that second one downloaded faster, even though it took a second longer, because it's totally usable at the 14-second mark, or at least they know something's happening. So that's perceived performance. So in terms of developing for mobile or for the web in general, just realize that mobiles are, you have these very, very powerful browsers in devices with low to crappy CPUs, or sometimes, some people might have better phones. We have not crossed the barrier of having better phones than computers yet. They're not plugged in, except for the 4 people here. A lot of countries and a lot of people, a lot of other countries, they do metered data. So here, like we have 10 gigs. For some people, that is metered. For me, I don't watch videos on my phone because I refuse to wear my granny glasses, so I can't actually see my phone. But for some people, 10 gigs is metered. For other people, they buy 32 megabytes and they turn their phone off when they're not using it to save battery because they don't have access to electricity. We're talking about tiny screens, and then we're also talking about different interactions. Here, most people think of mouse, but you're not actually thinking of accessibility. People are just using the tabs, or just the keyboard, no mouse, or touch. And then you have to think about battery, latency, memory, and responsiveness. So let's talk about some issues and solutions. So when we are developing, we are complete control in terms of the number of HTTP requests that we put into our sites, the number of bytes that adds up to. We can decide and code and program the images, animations, and interactions. We can do the squishiness. People call this responsiveness. I call responsiveness whether you can actually interact with your phone. To me, responsive web design is just making it squishy. That's not responsiveness. What we don't know is how the person's network is, their latency and their bandwidth, what hardware they're using, and what browser they're using and blocking features they have. So in terms of latency, when we are programming in our office, we have super powerful internet access, and we're going from our device to the modem and back. And so when it's doing a DNS request, the most, within your own Wi-Fi, it knows a lot of the IP addresses. When you're on a mobile device, your phone is going to the cell tower. That cell tower doesn't have the information you're looking for. goes to the phone company, which then goes to a DNS server, which responds with the IP address, which responds to the phone company, which goes back to the cell tower, which goes back to your device. Then you make a request for that IP address, which goes to the cell tower, which goes to the phone company, which goes to the actual server that that device is on. The area right here where these yellow dots are, that is where most of the latency occurs. So these mobile devices have way more latency than you do in the office. So what is involved in the page load? You make that HTTP request. It has to do a DNS lookup. You have to do the TCP connection. The request is passed back and forth, and then basically everything happens. There's certain things that block the rendering. So each request has to do a DNS lookup for each IP address. I mean, not each IP address, but each domain. Just remember that style sheets are blocking and scripts are blocking. So I included this navigation timing API, the metrics that we can measure, purely so that I could include the dark green, the orange, the purple, the pink, and the purple, or fuchsia, whatever. Because when you're looking at a web page test or the chart and dev tools, these are the colors that the browsers are using and that web page test is using. So this is to help people understand those charts. So latency is improved by using a CDN because you can have your assets closer to where the person is. So that's something that most people know about. Each connection requires a TCP handshake, which does take time. And SSL and TLS, that handshake takes 2 to 6 times longer. You still should use HTTPS and make your site secure, but realize that you are that there's a little bottleneck right there. And then in terms of Google just released last week Bbr Congestion Control on their cloud services, and my company does something called dynamic packet recovery. But realize that when assets are going from the server to your device, the bandwidth that you have is basically there's a bottleneck. And that is being resolved by Bbr Congestion Control and dynamic packet recovery. Basically, it goes as slow as the slowest packet that went. So when you lose, when there's a packet failure, basically that limits, I should put the picture in, that basically limits the bandwidth. And Bbr Congestion Control, which is just finally being released on Google Cloud, and I think we'll be able to see it soon, basically makes it so that you can actually reach peak bandwidth. Okay, so I pointed out the colors for this slide, and then for some reason I added 3 slides in between. When you are developing a site, do you see that pink that goes across the screen? That is JavaScript execution. When that is that's using the main threads. So when you are putting all of your JavaScript, so that's services.min.js from wired.com, which when you have those little white lines that go through it, that's kind of awesome because that allows the user to interact. But when you have that huge long thing, you're using up the main thread, and the users can't interact. So when you're developing, realize that responsiveness, responsive web design, if you want to design your app to be responsive, it has to be responsive to human touch. And when that pink thing is happening, the UI is basically frozen. It isn't actually frozen, but it looks frozen because it can't repaint while it's processing all that JavaScript. So what I didn't point out here is that long pink line at the end goes from 24 seconds to 37 seconds. That's 12 seconds. Wired takes 29 seconds till document complete. My site, I just like to show off a little bit. I did this website called Machine Learning Workshop. It was my April Fool's joke. It did not go over that well. I thought it was really funny, and I still think it's funny. That's why I include it in the slides. It's the machine learning school for machines that don't learn good and want to do other stuff good too. Why? see, you missed it out on April Fool's. Maybe I'll launch it again next year. So anyways, I made it into a progressive web app, most features, 90% of the way there. And it loads now actually in 0.8 seconds. But at the time I took this slide, it loaded in document completed at 1.2. So there's no JavaScript blocking anything. None of those pink lines, other than this right here, which is trying to find the client hints for that app. So back in 2015, Google came up with this notion called Rail. And they called it Rail because it's really Lyre. And Lyre just doesn't market very well. But it really is in order page load, idle, animation, and response to input. What you want to do is your goal is to load a page in 1 second or less. That doesn't happen. So like, don't think, oh my God, I didn't reach 1 second. You're not going to reach 1 second. Almost no sites load in 1 second or less, unless they're progressive web apps and they're loading directly from the cache. But if you're under 4 seconds, it depends what it is. A Hello World in 2 seconds is really slow. Game of Thrones trilogy in 18 seconds is super fast. So it's really relative. Idle, that long pink line that I showed you, you want to have it go idle at least every 50 milliseconds so they can react to human touch. Animation and scrolling, the timing that you want to do all of your JavaScript and all of your parsing in time for paint, so that it has time to paint, is a total of 16 milliseconds. So you want all your JavaScript to be in less than 11 milliseconds so that you have the 5 extra milliseconds to paint the page. That's the total is 16.67, so that you can reach 60 frames per second. And a response to input, when the human touches a button, you want that button to click down, put up, and show that it's actually reacting within 100 milliseconds. There are some things you can do to make it appear fast when you need more than 100 milliseconds. Eli Fitch gives this great talk on perceived performance, or speed perception, which is a little different than our speed perception. His speed perception is really about UI, and it's a brilliant talk, and it just went online on YouTube about 2 days ago. So when I said earlier that there's certain things in our control and certain things out of our control, we really can control the network to some extent, the latency and bandwidth, by not doing stupid things in how we develop, but we really can't control the hardware of the browser. So when you are doing performance, we have tools that we can use. There's something that's very old called YSlow. This is kind of the original, here are 16 rules that you might want to follow. Page speed, because people move from Yahoo to Google. Any company you go to probably has like 50% of the people were once engineers at Yahoo. I don't know what it is, but I'm also one of them. So page speed added some rules. Web page test is a tool, webpagetest.org. You can measure your performance. Developer tools has so many things to help you with performance. And then there's Lighthouse. Chrome came out, I believe, Chrome 60 came out yesterday. Now when you go to the audits tab, it is just Lighthouse. It used to be different audits, but now they just use Lighthouse. I'll cover Lighthouse in a second. So some of these rules are like minimizing requests. We have HTTP2 now, so people think that, okay, we can have like 56,000 requests. You do save time. It depends on how many requests you make and how big your requests are, whether HTTP2 is actually going to save you that much time. It's not the savior to the world. If you have 6 requests that are each 20 seconds long, and you divide them into many and use HTTP2, you still have the same amount of bytes coming down. So you're saving a little bit in terms of the connectivity and the handshakes, but you're not saving. I should do a talk and argue with everyone else in the world who thinks it's the bee's knees. And I still don't understand the expression bee's knees, because why is bee's knees? Are like bee's knees sexy or something? I don't know. You want to put your CSS in the head, JavaScript at the bottom. You want to, I forgot, my slides are, I just have to go like that to They're responsive, so I used a responsive font size. My font size is based on the width of the page, so if I want to decrease the font size, I have to actually bring it in so that I can read the bottom, because I was trying new things. Okay, so Lighthouse. The URL for Lighthouse is up there. It's a debugging tool, or not a debugging tool, but it's a tool to tell you, to audit your website and to tell you how good you're doing. It has 4 sections to it, so you just go into the developer tools. If you have Chrome 60, you can add it in an extension if you don't have Chrome 60 installed. It checks, there's a progressive web app checklist, there's a performance checklist, there's an accessibility checklist, and there's a best practices checklist. There's also page speed, which is an extension. Lighthouse is way better because it tells you exactly what to do and exactly what line you did it on, but it's not as good a tool to learn from. So if you want to learn about performance, read the page speed stuff. Lighthouse is still a little bit far behind. You have to go to the Google Docs, and it's just really long, and you're like, I still didn't find what I was looking for. So I'm still telling people to look at page speed, mostly as a learning tool. In addition to performance, these things here of minifying the JavaScript and specifying an encoding header and avoid imports and optimizing images, it gives you some usability rules too, like avoiding plugins and size content to the viewport. And very, very important, sizing tab targets appropriately. When you're on a mobile device, I have a fat finger and I have poor eyesight. Please target me, because I like to use my phone. You have to just think about how people are interacting with it, and use legible font sizes and image optimization. I'm just going to cover these. So I'm going to skip that one because I want to go deeper into this. These are my rules. It's not like this is, these are my rules and I'm correct. Let's just put it that way, right? These are the lowest hanging fruit. And this one is not on anyone's performance checklist, but I think it's the most important, which is configuring the viewport. So there's a meta tag called with the name of viewport, and these are all the properties you can use with device width, height, initial scale. It basically, the site on the left is Alexa without that meta tag, and the site on the right is Alexa with that meta tag. Which one is more legible on page load? The one on the left, you can see everything, but you can't see anything. The one on the right, you do have to scroll, but at least you know that you landed on the right page and you can read something. Basically, the viewport meta tag allows you to not be, I was polite when I said jerk. I kind of wanted to use a different word that started with an A. I can't read my Gmail on my phone without pulling out my glasses. Because it doesn't allow me to zoom. It says initial scale is 1.0, maximum scale is 1.0, minimum scale is 1.0, user scalable no, and width equals device width. So I have a pretty fat phone, but if I had a smaller phone, no one would be able to read it, even if they didn't need glasses. So don't be a jerk like Gmail, and just use the viewport. So even though that's not on anyone's performance, put that onto your performance checklist, because that is just so vital. The lowest hanging fruit, if you remember that circle, more than that I showed you, that graph, more than 50% of the weight of website at 3 megs or at 702 kilobytes was images. So to optimize images, you can gzip, remove image metadata, resize them, optimize them, and I'll talk about that in a minute. I'll cover all of these. So let's cover them. So gzip makes no sense, right? Images are binary. No, they're not all binary. SVG. Do gzip your SVGs, and there's an article on that, so I'm not going to go too much. Remove image metadata. There's a tool you can use to strip it right there, so this is a hopefully useful link. Resize your images. Don't just have one size of every one of your images. You want to serve the smallest image file for the screen size and resolution. You want to serve the scaled images. There's 3 things you want to do. You want to serve scaled images. You want to use the picture element or the source set attribute of the image tag. And for older browsers, you want to load just the smallest size images because if they don't understand a picture, they're basically an old version of IE, and those are only on computers, not on phones, and they're not going to be high DPI because you're not going to have a high DPI device with an old crappy browser on it. So serving scaled images, let me explain why you want to. You don't want to download unneeded pixels. So this is an example that I'm showing. That blue border is basically the wasted pixels, right? So when you have a small image and you have a 40 pixel, it's basically you're shrinking the image by 40 pixels, right? In this example, you're wasting 17,000 pixels. So you're sending bytes that you don't need. 17,000, you know. For the medium-sized image, or the second to biggest, I'll just skip one, that 40 pixels, when you're taking an image that's 640 by 640 and shrinking it down to 600 by 600, you're actually sending down 49,000 bytes that you didn't need, or pixels that you didn't need. And then the larger you get, you'll see that it's quickly at 800 went to 65,000. So when you have breakpoints on images, the larger the images, the more the breakpoints you want to have because you really are sending tons of extra bytes when you don't need them. And there's a really good article right here on that. So don't take my word for it. Take Jason Grigsby. Then scaling can be slow. It takes time to parse images that are the wrong size because it has to basically go through it twice. It downloads it, parses it, and then resizes it and parses it again. So in this example, this is an old one from Microsoft that Tobias Titus did. You can see the top run right here. All this blue is the CPU needed to decode. The green is frames per second, and the purple is rendering. But it's actually worse than it looks because this scale goes from up to 200, and this scale only goes up to 100. So you're talking about 4 times worse than it looks. So there's a site called Physics of Fast. Rule number 2, section 3, part B is the picture source and source set. Here is an example for you to use, if you have never used picture. You can take source, 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 and the last one always, always, always has to be the image element, or your picture won't work because it's not that's just wrong code. It might work, I don't know, I didn't try it. But that's also where you put the alt attribute, and if you don't put the alt attribute, it's not accessible, and we all want to create accessible websites. So optimize all the images. When you're doing, you want to do compression. You don't need to serve all of your images the same exact way you took it with your camera because these people are not going to take your picture and make a full-size poster out of it. They're just looking at it on a tiny little screen. And they don't need all the information from all the pixels. So there's a lot of tools that you can use to compress images without too noticeably degrading the quality. At the company I work at, we have this thing called Smart Vision that actually uses machine learning to do it on the fly. And if you're interested in learning more about that, I included that link. And then I included links to free sources that do it. And I did include links to paid ones that do it. Okay. Optimize all the images and serve the right image format for the device. So you want to serve the fastest image that browser can support. So Chrome supports WebP, and so does Opera. And generally that's a smaller file size. So one neat little trick is if you can figure out what the browser supports, like you know what browser your user is coming from, you can still serve it with that JPEG extension because a browser will decode any image no matter what the file name is if it understands the media type. Use the right image format. This is the smallest file size graph that I created. Chrome and Opera is WebP, IE9, Edge is JPEG XR. Safari is JPEG 2000, and Firefox does not support, or did not support any of these at the time that I wrote this slide, but they do have things that are light green on Can I Use right now. Reduce the number of images, leverage CSS, Here are some tricks, like here I have masking. So I needed to have something that it was transparent, like a frame, right? So here's my phone. If I just get rid of this, right, this is what it looks like. Oops. So you can see background image. Let's do this. And then back. See here, when I get rid of the WebKit mask, it doesn't show anything because I'm actually pulling in a JPEG that is solid. It is not transparent. I can make it transparent, oops, in the middle by using a mask. So in this way, this is a thing I created many years ago. In this way, I can serve a JPEG and make it transparent by using masking. Another thing you can do if you're only doing the outside here, masking works for the inside. You can use CSS clip path and clipping and shapes if you want to do just the outside. So I have examples, I don't know if I have it in this deck, of making a heart. Do I have it? No, I don't. Okay. So rule number 3. So rule number 1 was using Viewport. Rule number 2 is optimizing images. Rule number 3 is optimizing video. And I added this just this past, like this is new to the performance talks because if you look at this diagram from 2 years ago, videos on average were, hard to read, 204 kilobytes was the average video size. Today, as of July 1st, congratulations everyone, we are at 729 megabytes on average, kilobytes on average for video on your average homepage. That's crazy. That's a 3.5 times size increase in 2 years. So now we need to start really focusing on optimizing images. Easiest way to improve performance is to get rid of the videos. If that doesn't work, you can compress them. Optimize the source order of the ones that you've compressed. Make sure that you send the smallest one. And remove muted audio because people are sending audio with their hero videos. You know when you go to websites and there's a video as a background? People aren't taking the audio out of that, they're just muting it. So let's go a little bit over that. So omit the video. Like, do you really need a hero video on a mobile device? Just put a display none. It might grab the first part, but it won't stream the whole thing. I don't think it will actually stream any part of it. So just save on a small screen, don't even send that stuff. In terms of source order, in your video tag, when you have the sources, put them in order of which one is smallest first. So it will only download the first one, it only download one, the first one it interacts, sees that it can understand. So if it understands here WebM, it'll take the 10 meg. If it doesn't, it'll take down the 12, but if it doesn't understand MP4, then at 13 megs, the OGV one. Caveat here, do check the videos, because you can minimize an OGV down to like 1 meg, but you've lost so much quality that you still want a good experience. So do check for consistency, but do put it in order of size. That's like a tiny little change that can make a big difference. Then remove audio that is muted. So here is the video. When you see video autoplay true and looping and muted equals true, then the audio is probably a hero one. And there's a tool, and I highlighted it because it's a link that you can use. And with this code, you can actually output an audio-free version of the video, saving about 20%, which from a 10 meg down to 8 meg, that's a lot of savings. The AN in that thing stands for audio recording. There's very good documentation there. Okay, so I gave you 3 rules, and everything else comes after that, because those were the 3 really low-hanging fruit that we have a lot of bang for your buck. But definitely put your style sheets at the top, because you want your page to load pretty. You don't want it to look ugly and then have to repaint. And put your scripts at the bottom, async them, defer them. Remembering that JavaScript costs in terms of battery and performance, and when you're executing it, the site is not usable. Remembering that people are not plugged in. I already showed this, already went through it, I don't need to cover it again. Oh, no, this one. Remembering that when you are using JavaScript frameworks and you're parsing and executing, the site is not actually loading, that ping zone right there, that's the document DOM content loaded. That's a 2-second DOM content loaded on a desktop. It's 8 seconds on a mobile device. That's crazy. Minimize the DOM. The greater the number of DOM nodes that you have, the longer it takes to parse and execute and to rewrite the page. So if you're going to have like a table with oops, my time's up. I didn't know it would do that. I just have a few slides left. You know, if you're going to have hundreds of thousands in a row, replace. So like imagine you had this Tetris game. If every single DOM node that was put in was saved in the memory, how many times it would be repainting? When the row deletes, just reuse it up at the top. So when I was saying squishy, when Disney went with mobile, they made it squishy, they didn't make it responsive. They actually increased the requests. That's not performance, that's squishiness. Convert your site to HTTPS. It is a teeny bit slower, but it's worth the extra 60 milliseconds. Look at progressive web apps. These are websites that work offline. And definitely, it basically allows you to make a website that looks like a native app. Don't bother with AMP. That's my opinion. It will help you with search engine optimization, but it makes you lose complete control of your website. Your website will go faster, but you have no control over it. So here's the deal. Browsers have made a decision to refuse to renew any new advanced speed feature moving forward for unencrypted websites. That's why the HTTPS is worth it, among other things, not just the security, but a lot of new features like web workers only work with HTTPS. So in conclusion, always build with accessibility in mind. Build with mobile in mind. Test in real environments with lots of apps open, because that's the way your users are using it. Scale down, or preferably don't scale it up. Don't disable zoom. Take advantage of native features in the browser. Don't use prefix properties as fallbacks, because those only target older browsers that couldn't support that crap anyway. And follow everything that I just said today. And remember that your users may not be tethered. Their memory may be limited, and their bandwidth may be unreliable and metered. So always remember that, and just keep that as a mantra when you're developing. And if you have any questions, I'm going to be around through lunch, so you can ask me. And the last two things are the machine learning workshop that I joked about. It's up there. And then speed perception is a study, and I really hope it's an open source study to measure what metrics work best to measure performance. So please, if you have 5-10 minutes, take that. And that's it for my talk. Thank you.